To show us the food of our future, please welcome our next guest speaker from Maastricht University, MarkPost, and guiding us through the fireside chat from Selling and Business Insider, ArielKramer. Please welcome them to the stage. Take it away, enjoy.
All right, hi everyone. So did everybody have lunch? Yeah, so it turns out that Mark is the first scientist to grow a hamburger in the lab. So please, Mark, take it away. Tell us.
Sorry?
Tell us, how did you grow this hamburger in the lab?
Yeah, it's a very simple process. If we have a couple of slides here to show for it. We take, all our muscles have stem cells. And the cells are sitting just in your muscle, waiting to repair tissue when it's injured. And when it's injured, they start to proliferate and they start to make muscle tissue. And so what we simply do is take a biopsy from a cow, a very small piece of muscle that has a couple of hundred of those stem cells in them. Then we take the stem cells out, let them proliferate until we have trillions and trillions of cells. And then we instruct them to make muscle tissue because they are good at that. And so what we did in 2013, we made 10,000 of these muscle fibers, put them together in a patty, hamburger, cooked it and ate it, and said, well, you know, this can be done. We still need to kind of scale it up and get regulatory approval and all that sort of thing, but we essentially can do it. And also we need to do something because we cannot continue growing meat the way we are doing that right now.
And how did the burger taste?
It tasted, everybody asked me that.
I read it tasted good.
Yeah.
So.
No, it tastes like meat. The first hamburger that we made didn't have any fat tissue, so it was still a little bit on the dry side. And of course, taste also is a part of the fat actually also contributes to the taste. So yes, it was not complete, but it already tasted like meat. And the two tasters who actually ate it said essentially the same.
Right. So in the beginning, this was quite a luxury burger for 250,000 euros. It cost to produce this. And as of today, it costs 10 euros if you were to put it on the market. So can you please explain us how you got from 250,000 to 10?
Yeah, well, it's basically scaling up production and getting it into a production environment. This was an academic lab in 2013, expensive personnel, everything was handmade. So by scaling up, automating, you basically change a couple of things. You basically get to a reasonable price, but still way too much for like supermarkets. So to get from 10 to 1 or from 10 to half a euro will take a few next steps. Some of them are known, some of them we still need to explore.
And why a burger?
Yeah, well, the initial investor in this was Sergey Brin, and we thought of making a sausage from,
but he was anti-sausage.
From a pig and presenting it to the public with the pig kind of honking around on the stage. But then when Sergey started to invest in this, he said, by the way, it needs to be a hamburger. So that's why we made a hamburger.
There we go.
Retrospectively, it makes a lot of sense because hamburger is beef, and of course a sausage mostly is pork. And beef, from all the animals that we eat, cows are actually the least efficient. So from a resource efficiency perspective and from an environmental perspective, it makes much more sense to replace beef than to replace, let's say, chicken or even pork.
Right. So your company, Mosa Meat. So what are you currently doing? I know in the last 5 years you guys have done quite a bit. So what are your goals going forward, your overall mission?
Right. Well, we are improving the product, so adding fat tissue to it. Also improving the protein quality of the muscle fibers. And then mostly scale up. So developing all the methodologies to scale up. And once we have them at a stage where we say, well, this is going to be a blueprint of the final production stage, then we have to go through regulatory approval. So the company also has to file for regulatory approval because in Europe, for sure, it's going to be a novel food. And that means that you have to provide all the safety data to EFSA. to get this approved.
So what would you say is the biggest challenge when it comes to actually printing the meat?
The biggest challenge eventually, maybe not in the first 2-3 years, but eventually will be to organize the entire supply chain. So this is, in essence, a medical technology, very small scale. All the ingredients that you use are available at small scale. And I keep joking, if we start to pump out 50 kilos of beef in 2.5 years from now, nobody in the entire world can do any medical experiments anymore because we have consumed all the materials. So to organize that supply chain, we are dependent on a lot of other people, a lot of other industries that need to step in and need to provide the ingredients that we need to grow these cells.
Right. So as you know, I'm with the bioprinting company CellInc.
Right.
And everybody asks us, when are organs going to come to the market? When can we finally transplant an organ? And I imagine you get the same question for when can we start getting this meat onto the market? And when are we going to start 3D printing this meat as others have already done? Are you working in that space?
A little bit. We start to venture into that because with the current technology, which is basically relying on self-organization of cells into a tissue, not requiring 3D printing, you can make minced meat. You can make small fibers, small tissues. Once you start to, of course, a hamburger is fine and minced meat is 50% of the market, but in a way they are a byproduct of, let's say, ribeye steaks or filet mignons.
Right.
So it is our ambition to make a ribeye steak. And for that, then you need to do 3 things. One is you need to impose a larger 3D structure on those cells.
Okay.
And that's where 3D printing comes in.
Right.
Second, you need to be able to co-culture muscle cells and fat tissue in one block. It's doable, but you need to work on that. And third, probably most important, where also 3D printing comes in, you need to have a channel system, like blood vessels, to get oxygen and nutrients everywhere.
And that's the hard part.
We don't, sorry?
And that's the hard part as well.
Yes, we don't necessarily need the entire blood vessel, but we need a channel and perfusion system to deliver oxygen and nutrients in all the corners of that tissue and to remove waste.
Absolutely. So what are the most common questions that you get when it comes to, is this safe to eat, for example?
Yes. And of course, that's also where EFSA comes in. So I have been quoted to say that I look at the regulatory approval as sort of a marketing tool, right? Because that will eventually designate this as being safe. And of course, we don't have any issues. We don't have any reasons to believe that it's not safe because we are essentially making the same tissue, but in a different way. So it's completely reasonable that we have to provide that evidence. But once we have provided that evidence, then everybody can consider this safe.
Right.
I already consider it safe. I ate it myself. I gave it to a couple of people, and these were my friends.
So I remember you put an ad out in the newspaper, was it, to see if anybody wanted to try the patty? Is that correct?
Yeah. At some point, So people are naturally curious. It's kind of interesting. In a way, we are biologically programmed not to eat stuff that we don't know. Right? If you go into the forest and you start to pick mushrooms and you don't know what you're doing and you start to eat them, you're poisoning yourself. So that is a very common sense kind of characteristic. Yeah. But we are adventurous. So once we kind of dig into it, we can eat anything. Right, and so when I asked people, I needed courageous people to taste this for the first time. My email box exploded.
I can imagine.
Wanted to taste this.
Great. So, what made you get into? What sparked your curiosity to start working with this?
No, it was not so much curiosity as well. So we were doing tissue engineering for medical purposes, making blood vessels for bypass surgery, and at some point, this idea came up, which is already an old idea. Winston Churchill in 1932 already mentions this in a book, to use the same kind of principle to make food. And I was lucky enough to get into a project funded by the Dutch government where we could start working on this. And when I started working on this, I thought, wow, this is actually a much better application than my medical applications because, bypass grafts for people who are on their third bypass surgery is a good thing, but transforming the meat sector
It could change the world.
Is a much bigger thing, and I'm very much motivated by that.
That's great. So what do you think is the next steps? Are you going to be printing a bunch of other food? Is there anything that you in particularly want to print? Or if when you start going into 3D printing food, or any more food in the lab that you would like to grow that you find particular?
Well, if I think about 3D printing, I think of sort of the initial step.
Right.
So laying down the foundation.
Right.
After that, at least in my mind, you still need a lot of biological processes to make that tissue. So the 3D printing allows the cells to be in a certain format, in a certain shape, and then guides the cells to do their thing.
Right.
Right. So it's not. I have this sort of image that we all have, like a steak is coming out of a 3D printer and you can eat it. Right. No, it's the steak comes out of a 3D printer, and 3 weeks later, after it has matured and grown and developed itself, you can eat it.
Absolutely. So do you plan to bring this to Europe first? Is that where you're hoping to put this on the market initially and then spread it internationally?
We are doing this to solve a problem. I never started a company just for the company's sake. We want to solve a problem, and then you need to think of how are you going to do that quick enough. So yes, we eventually want to license the technology to as many people or companies who want to produce this. Okay. And of course, we will start in Europe because of the regulatory system and because we know the consumers best. But eventually it has to conquer the world.
Great. So we're actually getting quite a few questions. So I would like to maybe start with those. So we are going to go with the first question here. Is biotech food meat healthier than usual meat?
Say that again.
Is biotech food meat healthier than usual meat?
Right. It can be. It can be. So currently our goal is to make exactly the same. So that means that it has exactly the same health issues, and we know the health issues of processed red meat. But we can, of course, because we have everything under control, we can reduce the amount of fat, we can make the fat more unsaturated.
So you can essentially make it more lean.
Right. We can, once we know what drives the risk of colorectal cancer in processed red meat, and there are some indications, but not hard evidence, we can actually work on that and improve the healthiness of the product.
Great.
Yes, that is definitely an option.
Definitely an option. Fantastic. We'll move on to the next question, and that is, what is the energy footprint of this technology?
That's a hot question, because a lot of LCA analyses have been done on this, and a lot of assumptions have been made. So the opinion is kind of out there, the question. So some people say this is going to reduce the amount of energy. Some people say, well, we probably need more energy for this than for livestock meat. Currently, I don't know really the answer to that, because for that, the entire process needs to be fully matured and recycling has to be implemented and all these things. They're all now pretty much based on a lot of assumptions. What I do know is that in this particular technology, we don't need, we can choose the amount, not the amount, but the way we generate the energy, right? So greenhouse gas emission from livestock is partly just a biological thing from the animals, and not from the resources that go into it, but from the animals. They basically fart and belch methane, right? And they cannot help it. That's their nature. So the energy that we put in this system is basically electricity. And if you generate that from other resources and it is not associated with greenhouse gas emission, I'm actually not too worried about the energy component.
Okay. Do you have anyone giving questions about ethical dilemmas when it comes to this?
Well, yes. For me, there are two ethical issues, I guess. One is that you still use animals for human purpose.
Yes.
So we have to get those biopsies from the animals. There are ways to get around that, but currently we still need that. That's one issue, and most people would say, well, if you reduce the number from 1.5 billion cows to 30,000. I'm fine with that, and I would be one of those. But other people might still feel that as a problem. The second is a little bit more trickier, and that is that, of course, there's a massive industry dependent on current livestock beef production. Think about the feed industry, cattle farmers, slaughterhouses. Maybe we don't have too much sympathy for the slaughterhouses, but at least the cattle farmers have our sympathy.
So now it's jobs
right.
we're talking about.
Yeah, so if this works sort of at scale, if this works at scale, is this better? Okay. Then it's going to transform a traditional and long-standing industry. And you have to be very aware of that. Now, in my mind, this is going to take 10, 15, 20 years, so people have time to adapt. Absolutely. And it will create new jobs as well, of course, but yeah, it will change a system.
Absolutely. Well, we have about 4 minutes left, so I would like to get to a couple more of these questions. What are you feeding the printed beef with?
Right. We are feeding basically two chunks. One is glucose, amino acids, so all the building blocks to make protein. Right. Glucose as an energy source, and then vitamins and minerals for the cells to live and function. The second is like a mix of peptides that stimulate the cells to grow. Okay. We call them growth factors. We have them in our body. They stimulate us to grow, and we also have to use that for these cells. Great.
And somebody asked, do you think we will grow our own meat at home one day?
Oh.
Am I going to be making this in my kitchen, or what's going to happen?
Well, I don't think there actually will be any losers, other than the people who don't feel that the environment is important.
That's true.
I would not. So even with the farmers, we get that question a lot, and farmers will eventually change. They do whatever is necessary to extract value from their land. And these cells need to be fed as well. And guess what? This is coming from crops.
Of course.
So, we can integrate that in the system. But really the people who lose will be the ones who say, screw environment.
Of course.
And for me, they may lose.
Then they may lose.
Right.
To hell with it. So we have some other ones coming in. Will you go for gourmet cuisine being the next big thing after molecular cuisine?
I guess so. Our food desires are changing over time, right? And I think I call it kind of decadence. We get more and more decadent, meaning that we get more and more food choices.
Right.
And so all the varieties, we see all the ranges from organic, small scale, locally grown, to industrial, coming from far away, manufactured, highly kind of synthetic. And we will even see more variants of those in the future. The gastronomy kind of anticipated on that with molecular cooking.
Right.
And that will evolve as well. I once had a presentation at a 2 Michelin star restaurant in our town, and the cook became really enthusiastic because he said, well, now I start cooking before the meat is already there. So I kind of work with that process to make already kind of a special meat with different flavors, and then cook it. So he already started his imagination. How can I start?
So his wheels were already spinning.
Right.
He was ready.
Right.
Start printing. Fantastic. All right. So it looks like we have time for one more question. Will we be able to reproduce our whole planet one day?
Yes, it will. So if you think about the whole food supply, we're going to 10 billion people, and people are worried, can we produce enough food? If we cover waste, and we are wasting 40% of all our food that we are producing, if we cover waste, and if we take out all the inefficiencies in livestock meat production by, for instance, cultured meat, we have more than enough food on this planet for 10 billion people.
Fantastic.
It's not going to be a problem. I think eventually this cultured meat will replace conventional meat. Because I cannot imagine that if you go into the supermarket 25 years from now and you see those two products side by side, and you know them, and they're kind of the same price and the same quality,
But you know
that
one's
you
better.
would still select a product where animals have been killed. That ethics will change over time.
I believe so.
Animals have been killed, there are CO2 emission and methane emission, and all. Then nobody in his right mind will choose that product anymore. So in the end, in the far future, they cannot coexist, I think.
I agree. Well, thank you so much for your time. I'm going to come by your lab and have a burger. So it'll be great. Thank you so much, everyone.
Thank you.
Thank you.
Thank you. Thank you. Fascinating conversation. Appreciate it.